So now we understand information visualization, we can start to think of how we would design an information visualization system. So when creating a visualization system, you're really creating a user interface. It's an interface between the user and the data facilitated by a computer. And so data visualization systems are really graphical user interfaces. You're using the computer to graphically represent the data. So principles from user interface design are important in constructing a good, effective visualization system. You already have an understanding of the system, of how the graphics works in the system and how we display data with the system. And you have a good understanding of how users work based on what we covered in Module 1 of this course. We'll also need to focus on the goals. What does a user hope to achieve, and the tasks that they'll be performing to achieve those goals. And also the interaction. We'll need to be able to represent and understand the interaction of the user and the system. And, for example, describe a dialogue, a language of clicks and selections and so on, so that users can perform tasks in a way that's intuitive and productive. So we'll follow some standard sequences of forming a system design. Designing a visualization system is similar to designing a software system or other systems in general. We start with a basic requirement specification, and that's basically going to try to figure out what specific problems the system is going to solve, who's the system going to serve, and how will that person be able to make a decision based on your visualization system. This involves a lot of discussions with the user. I see focus groups used for this, but it's important that focus groups and interviews with the user aren't asking the user specifically what kind of interface or what kind of visualization system they want, because you're going to be the expert of the visualization system. Often the users don't know what's out there, what's available, what will serve them best, and so you want to focus on what questions they want to answer with the system and how can you get that information to them so that they'll have everything they need to answer those questions. Then there's an architectural design, and this is breaking the full system down into component systems. If you're making a visualization dashboard, then these would be the individual elements of that dashboard. And then there's a component design that you're going to figure out how to implement each of those elements. And then you go through a step of actually implementing, actually coding or setting up the system for each of these components. Then you do some debugging to test each of the components. And then an important step is user evaluation. Once you have these components, you'll want to make sure and test them with users to make sure they're doing what they're supposed to be doing, that the user is using them the way that you intended to use them. And also to use some statistics to make sure that you're not just basing your evaluation on anecdotal evidence, but that the user is actually using the system effectively. And then finally, maintenance, documentations for the system, and fixing. It's easy to underestimate this process, and when people make estimates of how long it will take to implement such systems, they focus on implementation. And you'll see implementation is maybe one of 7 steps here. And that's why we say when we're designing software systems or user interfaces or visualization systems, you want to take the amount of time you think it should take, and then you want to double it. And by doubling it, you're then realizing that you're going to have to be doing debugging and some component design. And then you want to double it again, because you also need to do the analysis and the requirement specification and the evaluation and the maintenance. And so we tend to underestimate by just looking at implementation. It really takes 6 to 8 times as long to actually create a system and when you're doing it right. Some other advice when making these systems is to use prototypes. We talk about user evaluation here at the end, but you should be doing user evaluations and user testings at every stage of this and checking with the user in some form or another, either with a model of the user or with the actual user. And so you want to use prototypes to simulate how the system might work. When you're doing a requirement specification and then move to an architectural design, for the architectural design you might want to have a mock-up of a possible interface and put that in front of the user to determine that that meets the requirements that the system needs to provide. Or you may even have a Wizard of Oz system where you simulate the system without it actually working the way it's supposed to. On a very specific case, you can hard code a system to work, and you can see if as you're doing component design, if that Wizard of Oz system, that simulation of the system you've designed, is going to satisfy it before you actually invest the time in implementing the system. You don't always have to go back to the user to get these answers. Often, especially as you're working on the design stages of the system, that you can use models of the user, of the task and dialogue. So the user model, based on the requirement specification, you'll have an idea of what goals the user will want to solve, and then you can start decomposing tasks and creating task analyses that go into the layout of components that can make sure that they meet the requirements as specified. And finally, as I mentioned before, don't wait till the very end to do this component testing. You'll want to test each of these if you've created a good model of the user and the dialogue and the tasks and so on. You can start to do some testing of your design before you've invested in the implementation time. So for user modeling, there's a variety of different techniques for modeling users. You want to focus on what the user needs to answer a question. You want to provide a visualization that will help the user answer a question. And you don't necessarily want to create the fanciest visualization or use every facility that's available on the computer system. You want to try to get into the head of the user. Try to look at the system from the user's point of view instead of, for example, the programmer's point of view or a system designer's point of view. And you want to know your user. What's the user familiar with? What other tools are they using? What's the user's role among other users or among other people in their organization? What might the user know and what might the user not understand? And then finally, what's the user's motivation in using the system? How can you best provide the information in a way that the user will want to use the system and know what to do to properly use the system? Finally, it's good to do a cognitive walkthrough. Put yourself in the head of the user and think and map out, write out in diagrams what should be on the mind of the user as they're using your visualization system, so that you can better present data based on what the user is currently focusing on. And so there's a variety of user modeling techniques. One of them is an old one is called GOMS. It stands for Goals, Operators, Methods, and Selections, and it helps you to understand what a user might be thinking of. Users are going to be goal-oriented, and so it's good to map out the goals for the system. It's also good to think of the operators as you're designing the system. What are the operations, the basic user actions that the user is going to be using to achieve the goals, and the user is going to be forming methods by stringing together these operations, and there may be multiple methods of achieving a goal. Which ones are you going to support? Try to support as many of them. There's more than one way to skin a cat. Users will have different methods to achieve a goal, and you want to be as flexible as possible in supporting those. And then finally, selections. When there's multiple methods, the user is going to have different ways of selecting which method to use, and you want to provide as much information as possible to be able to make an appropriate selection. A user is going to have a goal, and each goal is going to have a task or multiple tasks associated with achieving that goal. And so you want to make sure that your system can connect tasks into goals. And so this is a principle of user interface design called synthesizability. Is a user sitting in front of your system going to know how to use your system to arrive at an answer? If you have a visualization dashboard, is the user going to know where to look at on your dashboard in order to be able to come to a conclusion based on the information presented? And so these tasks often get complicated, and so you'll need to decompose tasks into subtasks and goals into sub-goals, and then tasks will follow a sequence, and those sequences are plans, and how can you articulate that plan so that the user can synthesize it when they're sitting in front of your visualization system. You may want to look at conditional tasks, when a selection needs to be made. What are the triggers for a conditional task? When does a sub-window need to be opened? When can some operations be avoided? You might also consider wait times, delays in information in processing, or when the user is interrupted, cyclic tasks, or multiple parallel tasks. And then you can use all of these results to sort of imply the best dashboard layout that best facilitates the user getting the information they need to be able to make a good informed decision. And so here's some examples of dashboards. This is an old dashboard from 2001 SIG-Chi visualization, but it would still be used in modern contexts. It's used if you're monitoring news groups or online conversations. We've had these for 15 years and longer. And this one's shown to work really well. It starts with a thread tree, and it's basically a conversation with a subject and then people replying to that subject, and other people are replying to the original subject, and people replying to the second reply to the original subject, and so you get this tree-like behavior. And it's organized chronologically, vertically, but then you form a hierarchy based on replying, on which messages reply to which other messages. And then you've got the users, and the users are provided here in this second visualization. And you have kind of a Gantt chart called a piano roll, and it's basically corresponding to posting which messages in time horizontally, and then you've got it sorted vertically by the number of posts. And then you've got this sociogram. In this case, it's just a social network, just a graph where you've got connections based on who's replying to whose message. But the horizontal and vertical position of nodes is indicating horizontally the number of responses each person sends, and vertically by the number of responses they get. And so this original poster is getting a lot of responses, and the rest of these are getting some responses to their posts. And then finally, you want details on demand. You've got this detail selection, so you can select a node here and see it. You can select a person here. It gets highlighted in the thread tree here, and you can select an individual node here and see what the actual post is in order to drill down to those details. Another example of a dashboard is the CDC Center for Disease Control flu view, which shows in the U.S. How the flu is progressing through the year and which strains of the flu are occurring. And so you can see peak times for flu, which strains of the flu are happening. You get a map here, so you can determine by region. For example, this is the region where the University of Illinois is, and I can see which flus I should be on the lookout for and which times I should be on the lookout for, and I can start to make a decision based on this data how at risk I am or other people I know might be at risk for the flu. And there's also a University of Illinois at Urbana-Champaign strategic plan dashboard, and we have a strategic plan that has several elements. For example, fostering scholarship, discovery and innovation, providing transformative learning experiences, societal impact, stewarding resources, and then we have individual graphs in our dashboard that we can select for each of these elements that tell us how we're doing on each of these elements. But the graphs also don't just give the raw data. They give, for example, goals, where we want to be with some of these elements. In some cases, we're doing well compared to our goals. In some cases, we're not doing as well compared to our goals. And then that can motivate us to do a better job. So following these design rules, these sequences for designing a visualization system, you can start to design your own dashboard that focuses these visualization tools on your own data so you can use it to make better decisions.